Hello everyone, this is the second part of my set of two-step videos. So in this video we're going to go through an applied question. This is question 12 from 2017 and it's a probability and stats question. And as for why I chose probability, it's just that I don't like mechanics, and I actually don't think I did any mechanics in the final step exam. I did, I think it was 4 pure and 2 applied in both. Sorry, 4 pure and 2 stats in both step 2 and step 3. I didn't do any mechanics. So anyway, this question is quite interesting because I think that it's conceptually quite difficult. And there's also some tough algebra. So all in all, like, I don't think this is the kind of question that I would recommend you do in the exam. But maybe it's one I might have tried anyway because I quite like probability. So let's give this a go. So I'll give you a few minutes to read the question, and then I'd say spend about 20 to 30 minutes doing it yourself. And then when you come back, we'll discuss the problem. Okay, so I'm assuming that you've paused it and had a go. Okay, so basically our scenario is that we have Adam and Eve catching fish, and then X is the number of fish that Adam catches in time t, and then that's a Poisson with parameter lambda, and then Y and mu and so on for Eve, respectively. So basically we're told both variables are independent. The first part, this you might not have seen this at A level, but actually it is like a calculation that's pretty standard for the first part of step questions. So basically, we want to find the distribution of x plus y. That's the total number of fish caught by both Adam and Eve in time t. And basically, we can just split this up. So the probability that x plus y equals r, that's basically just the sum. We can do this from, I equals 0 up to r of the probability that x equals I times the probability that y equals r minus I. So that's basically I plus r minus I is r. And then we're allowed to do this basically because x and y are independent. That's what it says in the question here. And then you could do this calculation. You should know the formula for Poisson off by heart, because by the way, by contrast to earlier step years where they used to do a formula booklet, they've stopped giving formula booklets, so you do have to learn the formulae now. And basically, you find out that x plus y is distributed Poisson of lambda plus mu. So it's just the sum of the two means. Okay, so that's the first part. And then, so the first part should be quite straightforward. Second part is also not that bad. So you're told, given that Adam and Eve catch a total of k fish in time t, where k is fixed, show that the number caught by Adam has a binomial distribution. So you're basically looking at the distribution of x, given that x plus y equals k. So you want to do some sort of calculation like the probability of that x equals a given that x plus y equals k. And remember that this is conditional probability, so it's going to be in the denominator the probability that x plus y equals k, which you should have calculated in the previous part. And then in the numerator there's going to be the probability that x equals a times the probability that y equals k minus a. That is, the probability that x equals a and x plus y equals k. Okay, and then if you do that calculation, you basically get an answer. So it turns out that this distribution here is a binomial with n being equal to k, and then the probability being lambda over lambda plus mu. Okay, so that's part 2. And then now part 3. So, okay, when you first look at part 3, you should be a bit confused. So given that Adam and Eve start fishing at the same time, find the probability that the first fish is caught by Adam. So that's actually quite tough. And when I first saw this problem, my mind was going in all sorts of places, and I was thinking about finding some sort of like finding a variable for the time taken for Adam to catch his first fish and the time taken for Eve to catch her first fish, and it's like the probability that the first variable is less than the second variable, and that's like a continuous variable. It's very horrible, but basically you don't want to be doing it that way. If you're stuck, remember the first bit of advice is to always try and apply the previous parts. So I would first go to part 2 and see if part 2 is useful. And it turns out if you do a bit of thinking that it is actually just an immediate application of the previous part, because you can just say that basically what we're trying to find is the probability that given that Adam and Eve have caught one fish, that Adam has caught one fish. So that's basically k being equal to 1. And you can see that actually, logically, that's the same thing as the first fish being caught by Adam, because you're just looking at the probability that, given that one fish total is caught, that fish is caught by Adam, i.e. Adam has caught the first fish. And it turns out the probability is lambda over lambda plus mu. Which makes sense because the previous was a binomial and the probability was lambda over lambda plus mu. Sorry, that is p is lambda over lambda plus mu. Okay, now the last part is, I think, quite interesting. So you're now given that you're told basically that any Poisson distribution with parameter theta, the expected time from any starting point until the next event, that is the event described by the Poisson distribution, is 1 over theta. So you want basically the expected time from the moment Adam and Eve start fishing until they've each caught at least one fish. So again, I tried some really weird and wacky stuff, like, for example, setting up maybe a parameter that that's like the time taken for them both to have caught at least R fish, and you want like the probability that parameter is equal to 1, but you don't need to do that. So the trick here is to sort of split it up into 2 bits. So in the first bit, it's just the expected time until basically one fish has been caught, and that's going to be 1 over lambda plus mu, because remember that x plus y is distributed Poisson of lambda plus mu. So basically, and if we look at the first sentence of this part, so this is a Poisson parameter theta, so we want 1 over theta for the expected time from any starting point, i.e. the moment they start fishing, until the first event, that is x plus y being equal to 1. So we have basically a 1 over lambda plus mu. So that's the expected time until one fish is caught, but we now need to split it up into 2 cases. So either Adam has caught the first fish, and as you know, that happens with probability lambda over lambda plus mu. And then now what we want is essentially, so Adam has caught the first fish, and we need them both to have caught at least one fish. So it's the expected time until Eve catches her first fish. But remember that we can, for this Poisson distributed parameter theta, we can actually pick any starting point. So I'm going to pick as a starting point the moment in time that Adam has caught one fish. So then the expected time until the next event, i.e. Eve catches her first fish, is just 1 over mu. So it's going to be 1 over mu. And then the next case is that Eve caught the first fish, and that happens with probability mu over lambda plus mu. And by the way, I didn't have to do any big calculations. It's just going to be 1 over this quantity here. Sorry, 1 minus this quantity here. And then just by symmetry, we just now want expected time until Adam catches his first fish, which is 1 over lambda. And so you can tidy and simplify this to get the final answer. And by the way, if you're just stuck on what I've done a bit of conditional expectation here. So so what I've done is basically conditioning on Adam catching the first fish and then Eve catching the first fish, and then I've just now added up the times like so. Okay, so hopefully that was clear. And yeah, thank you for watching both of these videos, and I hope you've gained something from it, and you've developed more confidence when tackling STEP questions.